All right, guys, so in this video, we're going to factor polynomials by grouping, okay? Specifically, polynomials with 4 terms, as you can see in this example here. 1, 2, 3, 4-termed polynomial, okay? So when a polynomial has 4 terms, what we can do is we can make 2 different groups out of these. We're going to group, let's just say we're going to group the first 2 together. Okay, notice I put those in parentheses. And we're going to group the last 2 together. Okay, so we make 2 different groups, and we're going to factor out a GCF. Okay, we want to see if there's a GCF between these 2 terms and a GCF between these 2 terms. Okay, we want to make sure the polynomial is in standard form. This one already is, excuse me. It doesn't have to be in standard form. It's just something I think you should always be in the habit of anyway, so I bring it to your attention here. Okay, once we've taken out the GCF, okay, we should have a common binomial factor. If the common binomial factor isn't there, there might be one extra step we can do to make it a common binomial factor, but if we can't do that, then that polynomial can't be factored by grouping. Okay, so this is going to work for 4-termed polynomials in very specific cases. All right. Once we find that common binomial factor, we're going to take it out. Okay, and our answer is going to be the product of 2 binomials. Okay, and then as always, we can check our work just by doing the distributive property and seeing if we get what we started with. Okay, so in number 1 here, we've already grouped the first 2 terms together and the last 2 terms together. So 12x cubed and 9x squared. Let's think about the GCF there. So the 12 and the 9 are both divisible by 3. The x cubed and the x squared, they're both divisible by x squared. So my GCF for this first set of terms is 3x squared, okay? So remember, I'm going to divide both of these by that. 12x cubed divided by 3x squared is 4x. 9x squared divided by 3x squared is 3. So I'm left with 4x plus 3 on the inside. But again, remember that GCF doesn't disappear. It still has to be there to make sure we maintain equivalence. All right. The second set of terms here, the second pair, 20x and 15, both divisible by 5. So when I divide 20x by 5, I get 4x. When I divide 15 by 5, I get 3. Okay, and notice I've got my common binomial factor, 4x plus 3. Okay, so I'm going to write my answer here as the product of 2 binomials. So I'm going to group the ones in red here. That's why I color-coded those in red. I'm going to group those together as one binomial. And then my common binomial factor is going to be the other factor. So that's going to be my answer. All right. I'm not going to work it out here because I want to keep the video short. But if you multiply this by times this by, you're going to get the 4-term polynomial that we started with. Okay. So that's how you factor by grouping. So let's give number 2 a try. So notice we've got this 4-term polynomial. Notice it's not in standard form, so I want to rearrange it first. I want the z cubed to come first, then z squared, then z to the first, and then the constant. Okay? Just like we did before, we're going to group the first 2 terms together in parentheses, and we're going to group the last 2 terms together in parentheses. Okay? So within the parentheses, I want to look for a GCF if there is one. Okay? 9 and 18, both divisible by 9. So the greatest common numerical factor is going to be 9, z cubed and z squared. So I can take out a GCF of 9z squared. Right? What's going to be left in parentheses is what I get when I divide these 2 terms by that GCF. So 9z cubed divided by 9c squared is just going to be z. Negative 18z squared divided by positive 9z squared is going to be negative 2. Okay? So let's look at the second pair of terms here. So z minus 2. Well, these don't have anything in common, but if you'll notice, I've already got a binomial here that matches the one I just got when I factored the first 2 terms. Okay? So remember, if these 2 terms don't have a GCF, I can always think of that as just taking out a positive 1. Okay? There's already an understood 1 there, and I'm not changing this binomial. It stays the same. The reason that's okay is because it matches this other binomial I got in the first step. Okay? So just like we did up here, I'm going to group the red terms together in my first binomial. My common binomial z minus 2 is going to be the second part of my answer. And that's going to be the answer for example number 2. Again, do the distributive property, multiply this by times this by, and you'll get what we started with, okay? Or you'll get this once we transformed it into standard form, okay? So that's factoring by grouping. In the next video, we'll see what happens when these, the binomials here in blue, the common binomials, are actually opposites, all right?